Let's discuss a question from heat transfer. We have been given a plane wall whose thickness is 1 meter. So this is 1 meter, and at the left face the temperature is 300, at the right face it's 200 degrees Celsius. The value of the conductivity varies linearly, so the value at the left face is given as 25 and at the right face it is given as 15. Okay, now the conductivity varies linearly, so I'll just assume A plus BT because I don't know. Now constants AP I can find out because at left face I know the temperature, I know the conductivity value. At the right face I know the temperature, I know the conductivity value. Substituting in this, well, 20 at the left face it's 25 A plus B, the temperature is 300. At the right face it's 15 A plus B, it's 200 degrees Celsius. Okay, so if I add or if I subtract 1 minus 2, if I do, so it's 10 on the left side, it's B into 100 on the right hand side, so this gives B as 1 by 10, and that if I substitute in the first in the second equation, let's say to get A value, it's A plus 20 because 1 by 10 20, and A is minus 5, so K is minus 5 plus T by 10. This is how K varies. Now in a steady state heat conduction, what is constant? If you remember the basic equation for one-dimensional steady state heat conduction, this is the thing for 1D steady heat conduction. This is the basic equation. So this means that now if flux is minus K dt by dx, so by these two equations, if you substitute this, you will get that dq by dx is 0 with the minus sign which gets cancelled. So Q is constant. That is what I get. Q is constant. Heat flux is constant in a steady state, and in a normal sense, because K is constant, when you have a normal thermal conductivity which doesn't vary with temperature, so we say the temperature gradient is also constant. But here Q is constant but the temperature gradient is not constant. That is very much important. So minus K dt by dx is constant. Now constant I will assume C, and I need to find out that, right? Minus K dt by dx C. Now C is something which I need to find out. Now K variation I got, so let's substitute minus 5 T by 10. dt is dt. I take dx that side, so it's dx, and so it's 5 minus T by 10. It's dt is equal to C dx. Okay, now I need to find out C. C is constant, remember, so I'll integrate with the lower limit 300 degrees Celsius temperature and 200 on the right hand. So this is integration symbol, and on this also if I apply integration with 0 and 1 meter. Okay, so if I'm just integrating here, so it will be 5t minus t square by 20. Now the upper limit is 200, the lower limit is 300, and on this side it's c into x, which is 1 by substituting upper limit. So this becomes 5 200 minus 300 minus 1 by 20 200 square minus 300 square is equal to C. So this value is minus 500, and this if you find out, this comes out to be plus 2500. So this is 2000 C. So remember that C is a constant and C is your heat flux. Okay, so it's 2000 watt per meter square, and the answer is A. That's a very good question on heat transfer, where heat flux is constant in a steady state. That is always true, but the temperature profile is not linear. That means temperature gradient is not constant because your K is not constant. K is temperature dependent. So dt by dx, K into dt by dx is constant, but because K is not constant, is temperature dependent, so dt by dx is not constant. So remember that. Answer is A. Thank you.